Okay, we're going to pick up on example 4. So we finished example 4 yesterday and we identified critical numbers, increasing, decreasing, relative max and min. Can you guys go ahead and look at the answers that we got, and I want to match them up with the graph. So we analyzed x squared over x minus 3, which is this curve. If we look at the graph, look what we have. So looking at the data for step number 2, and we were looking at increasing. So we said increasing from negative infinity to 0, negative infinity going to 0, you can see f is increasing. We also said f is increasing from 6 to infinity. You can see 6 all the way to infinity. We also said decreasing from 0 to 3, and then we picked back up from 3 to 6. Remember, there was a vertical asymptote at 3. That's why we didn't say from 0 to 6. We also said we had a relative max of 0 at x equals 0, right there. And the reason would be because f prime changed from positive to negative. We had a relative min at 612, I believe it was. Yes, a relative min at 612 because f prime went from negative to positive. So here was our relative min. Okay, so you can see, I think looking at the graph, why, you can see the vertical asymptote going through here, and then you could also see the relative max and min and all the increasing, decreasing. Okay, I just wanted to go over that with you. Now we're going to go on to, let's see, the next one. Okay, so we have to go through the same process. We have to find critical numbers, increasing, decreasing, relative max and min. Well, first, remember, we always want you to check the domain first. So this domain is going to be all x, but x can't be 0. Okay, now on to find critical numbers. So we have to find the derivative. So the derivative is going to be the bottom times the derivative of the top. Remember, low d high minus high. D low is 1, all over low, low. And then if we keep going, we're going to get 3x cubed plus x minus x cubed minus x. So then we're going to get 2x cubed over x squared, which leaves us 2x. Okay, so here's our derivative. Now, to find critical numbers, we need to find when the derivative is 0 and also when the derivative doesn't exist. Now, looking at this derivative 2x, it's going to exist everywhere. So this isn't going to matter, but this won't matter. But the derivative equal to 0 does, and you get x is 0. Is that a critical number? Derivative is equal to 0. Anyone see the issue? Here's the issue. 0 shouldn't exist to begin with. So in this case, there is no critical number. Okay, going on to part 2. Part 2, we have to note increasing or decreasing. So let's look at our interval, our sign of f prime, and our conclusion of f. Our domain was everything but 0, so we have no critical numbers to incorporate into our table, but remember our table has to include, or our chart has to include critical numbers and discontinuities. 0 is a discontinuity. So we're going to go from negative infinity to 0 and 0 to infinity. I'm going to look back at f prime. F prime is down here. It's a 2x. So if I sub a negative in, I'm going to get a negative. If I sub a positive, I'm going to get a positive. What does this mean? If the derivative is negative, we have f is increasing. If the derivative is, I just said that backwards. If the derivative is negative, f is decreasing. If the derivative is positive, f is increasing. So we can now say our answer. F is increasing on 0 to infinity. Remember, we need a reason. Because f prime is positive. F is decreasing on negative infinity to 0. What's our reason? Because f prime is negative. Okay, third step. Find relative min and max. Okay, see if you got this down. Derivative goes from negative to positive. So at 0, let's see, negative to positive is like this. So at 0, that means that we will have a relative min. Do you guys agree? Well, wouldn't this occur at 0? And what was up with 0? Nothing existed to begin with. Okay, so we would say there is no relative min or max. There is no relative max or min. And then this is just a note to you. Even though the sign of f prime changes when x equals 0. And actually, we didn't really need to make this capital, right? We can just make this one sentence. There is no relative max or min, even though the sign of f prime changes when x equals 0, because x equals 0 never existed to begin with in the function. Okay, let's look at the graph real quick. You know what, before we do this though, can we analyze this on our own? Look at over here. Let me get rid of this. And let's just draw a little note over here. If you guys have x cubed plus x over x, remember you can take a x out and don't those cancel? And then you get x squared plus 1. Remember, if they cancel, it's called a removable discontinuity, and there's a hole at 0. Okay, so if there's a hole, we can't have a relative max or min. Okay, on to day 2. Okay, same directions. Find critical numbers. Critical numbers are going to be when the derivative, which is 2 for x less than -1, and 2x for x greater than -1. We need to find when the derivative is 0. And that is going to be, so we're looking when the derivative is 0. Do you guys see that this can never be 0, but this can? So we're going to go ahead and set 2x equal to 0. We also want to see when the derivative doesn't exist. Do you guys remember for the derivative to exist that the left and the right have to be the same? So if you can imagine this right here, at -1, these are not the same. So the derivative does not exist when x is -1. And let me write that. Okay, so 2 cases for a critical number. Derivative equal to 0, we'll solve for x. Derivative does not exist, and that is at -1, because this would be 2, and that would be a -2. Okay, so this is x is 0. So here's our critical numbers, and we're on to step 2. Okay, I'm going to have to maybe write a little smaller to get all this in. Step 2, we need to make our chart. So we're going to have interval, we're going to have sign of f prime, and we're going to have the conclusion of f. We need to go from -infinity to -1. We need to go from -1 to 0, and from 0 to infinity. Now, when we go to test these, we have a piecewise, so we have to be careful. Let's pull the piecewise up. Okay, this is less than -1. So when we go to test these in the derivative, we need to choose x is less than -1. Okay, and you can see here that you'll get a 2. We don't care that it's 2, we just care that it's positive. Now, when you pick a number between -1 and 0, how about -1/2? Okay, so it really doesn't matter, but just between -1 and 0, that is still, or that's going to be in this piece now. Okay, so when you sub something in here between -1 and 0, you're going to get a negative. And then the last piece, if I'm subbing a positive number in, I need to use this piece, which makes this positive. Okay, what does that mean about f? The conclusion of f, it means f is increasing, decreasing, then increasing. That's the first part, so let's give this reason. F is increasing where? F is increasing from -infinity to -1 and from 0 to infinity. Why? Because f prime is positive. F is decreasing. Where is f decreasing? From -1 to 0. Why? Because f prime is negative. Okay, to go on, we have domain is all real numbers. I meant to mention that. Sorry, I forgot about that. Okay, so now when we have relative max or min, look right here. Now again, this is just a sketch to illustrate. This is not the answer. But if I go from increasing to decreasing, relative max, decreasing to increasing, relative min. So let's go ahead and state that. There is a relative max of, we'll fill this in, when x equals -1, because f prime changes. What does f prime change from? Positive to negative. Okay, I'll fill that in a second. Let's get our sentences down. There's also, oops, let's fix that. Okay, there is also a relative min of, we'll fill that in, when x equals 0, because f prime changes. What does f prime change from? Negative to positive. Okay, I need to find out what the max and min are. So what I'm going to do, I'm going to go ahead and sub a -1 back into the function to see what I get. So a -1 is right here in this region. If I sub a -1 in, I'm going to get a -1 out. Okay, the min, where did the min occur? The min occurred at 0. We said that right there when x is 0. So I'm going to go ahead and sub a 0 in. 0 is in this piece because you can see x greater than or equal to -1. If I sub a 0 in there, I'm going to get a -2. Okay, done with C. Okay, there was a D. We're going to skip it and go right to E. Okay, notice here we have a restricted domain and we have some trig. Okay, so to find critical numbers, we are going to take the derivative. But remember, before we take the derivative, we want to rewrite this as cosine squared plus sine x. Remember, we like looking at this where we have the cosine in parentheses because it reminds us about chain rule. So the derivative is going to be, remember our inside stuff. So we pretend that inside stuff is just a u and we bring the 2 down. We rewrite that to the first power. Then we take the derivative of the inside stuff. The derivative of sine is cosine. Now we're going to factor out a cosine. How about we take out a negative cosine? That will leave us with a 2 sine minus 1. And let's set this derivative equal to either 0 or where the derivative does not exist. The derivative will exist everywhere, so that's not an issue. So we are going to go ahead and set this equal to 0. This is going to give us either cosine is 0. Well, we could put a negative, but you can divide to get rid of the negative. And then we'll have this. So now sine x equals 1/2 or cosine is 0. Let's look at our unit circle. Cosine is 0 at pi over 2 and 3 pi over 2, but we don't want 3 pi over 2 because that's not in the restricted domain that they gave us. Where is sine 1/2? Sine is 1/2 right here at pi over 6 and at 5 pi over 6, and both of those are in the domain that they gave us. Okay, so there are our critical numbers. Now let's go on to step 2. Increasing or decreasing. Before we do that, remember we have to make our table. You know what? Actually, I think I have more space down here. I'm going to go to the bottom and make it. Okay, so we have the interval. We have the sign of f prime, and we have the f conclusion. This pen isn't being super clear today. Let me fix that. Okay, the interval. We're going to go from 0 to what's next? Pi over 6. And then we're going to go from pi over 6 to pi over 2. Then we're going to go from pi over 2 to 5 pi over 6. Then we're going to pick up at 5 pi over 6 and head to pi. The sign of f prime. Okay, so let's see, where are we? Here's the sign of f prime. So here's f prime. We're looking at this. We're just ignore the fact that it's 0. Okay, between 0 and pi over 6. Now we want to be quick about this. We don't want to spend too much time. I can imagine we probably wouldn't have a calculator. So we are just going to have to think of pi over 6 and 5 pi over 6. We're trying to just figure out positive or negative. Okay, we don't need to compute values. Cosine over here is positive because x is positive in this quadrant, but the negative here makes it negative. Now, what's the sign here? Isn't the ordered pair here √3 over 2 1/2? So the sign value here has to be less than 1/2. So I make anything up. Let's just say 0.25, a fourth. So if this is a fourth, 2 times a fourth is 1/2. 1/2 minus 1 is negative, times a negative gives me a positive. Okay, this is pi over 2. Let's go over here now. So in this quadrant, if in this region, cosine is still positive, but the negative there makes it stay negative. Okay, if I'm looking at this next ordered pair that you guys probably know, which is 1/2 √3 over 2, right? What if I sub that in? So I'm going to have double that. That's what this says, which would give me √3. √3 minus 1 is positive, and a positive times our negative is a negative. Pi over 2 to 5 pi over 6. Now I'm over here. Okay, this point over here is going to be -1/2 √3 over 2. just picking anything in that region. So cosine right here is negative, times a negative is positive. If I'm using root 3 over 2 for my sine, if I double that, I get root 3 minus 1, and that is positive. Again, if you need more help with this in class, I'd be happy to help you. 5 pi over 6 to pi. I'm in this little region here. Cosine over here is negative, but it already is negative, so now it's positive. If I look right here, I need a y value. So what's a y value? Because that's what sine is. Couldn't it be 0.25? Because it goes up to 0.5. So let's say a fourth doubled is a half, which is negative. And this was positive, so we're left with a negative. So what does f do? F goes from increasing to decreasing to increasing to decreasing. So now we can go ahead and talk about our increasing and decreasing behavior. So we could say f is increasing on, let's see, 0 to pi over 6, and then pi over 2 to 5 pi over 6. And what would our reason be? Because f prime is greater than 0. F is decreasing. When is f decreasing? From pi over 6 to pi over 2, and then from 5 pi over 6 to pi. What's our reason there? Because f prime is less than 0. Okay, so that was kind of a unique way to look at the unit circle. We're just trying to get values for x and y. Okay, now on to 3. Relative max and relative min. Let's go over here and look at this. If I go from increasing to decreasing, relative max. Decreasing to increasing, relative min. Increasing to decreasing, relative max. So we have 2 relative maxes and 1 relative min. So let's go ahead and state that. There is a relative min at, where was the relative min? It was right here at pi over 2. I have to find the y coordinate. So there's a relative min at pi over 2. I'm going to come back to this because what's the same reason always, guys, for relative min? F prime changes from negative to positive. Okay, then we're going to have a relative max. So there's a relative max at, go back to our chart, we have 2 relative maxes. We have one at when x is pi over 6 and 5 pi over 6. So at pi over 6 and 5 pi over 6, how do we know we have a relative max? Because f prime changes from positive to negative. Okay, guys, we have to get these y values, so let's go ahead and get these. At pi over 2, let's go back to our function. Okay, so we just have to sub numbers in. At pi over 2, where are we? We're right here. Cosine is 0, so that's gone, and sine is 1. So we know that this output is 1. Okay, let's go on to pi over 6. Let's see, let me do this math up here. At pi over 6, so f of pi over 6, what's cosine? I'm looking over here. Cosine of pi over 6 is going to be root 3 over 2 squared. What's sine there? 1/2. So this is going to be 3/4 plus 2/4, which is 5/4. At 5 pi over 6. Okay, so now we're right here. We need to find the output at 5 pi over 6. So we're going to have f of 5 pi over 6, and 5 pi over 6, if we're looking on the unit circle, is right here. It's going to be really similar, right? The cosine is now negative, but it's being squared, so negative root 3 over 2 squared, plus the sine is still 1/2, so we're going to get another 5/4. Okay, so we gave increasing, decreasing, and all our reasons. We are out of this section. Okay, let's go on to 5. What can you conclude given the information below? So we're leaving all of this work now, and now we're just talking about a couple quick problems. If f is differentiable for all f, what does that mean? Okay, remember differentiability implies continuity, so we know f is also continuous for all x. What happens on the next line if f prime is negative? That means f is decreasing on this interval. F prime positive, f is increasing on this interval, and if f prime is less than 0 on the next piece, f is also decreasing. So what can we conclude? Like, these are just some observations, but I think we could be a little fancier. We could say that there's what's going on at -1 or at -6? Look right here. So I'm starting over here at -infinity, and if I go up to -6, I know that f is decreasing, so I have f is decreasing, and then at -6, f increases. So there should be a relative min when x equals -6. I don't know what the output is, and why do we know relative min? Because f prime changes from negative to positive. What happens as I go on to -1? So from -6 to -1, we keep increasing, and then from -1 to 10, we decrease. So from -6 to 1, I'm increasing, and then -1 to 10, I decrease. So at -1, there should be a relative max. So there's a relative max when x equals -1 because f prime changes from positive to negative. Okay, so there's our conclusions we can make. Going on to 5, just continuing with 5, I just wanted to explain what this means. I want to say there was something like this in your book, and I thought you might need help with it. So if we want to find the sign of h prime of c. So I was looking at example 5 up here as though it was separate, but all of this is going to pertain to what we're using right here. Okay, so I wanted you to be able to see this information and make these conclusions, but we're really going to use it to find the sign of h prime. Okay, so h prime of x, 4 is a scalar, and the derivative of f is f prime. The derivative of a -4 is 0. Now they're saying, can you find h prime at -7? It's going to be 4f prime of -7. They just asked us to find the sign. We're not finding the value. What is f prime of -7? We'll look up here. -7's in this, and f prime is negative. So 4 times a negative is just negative. So h prime of 7 is less than 0. Okay, that's all these are asking when you get to these problems in your book. Let's do another couple. Again, I totally think you could pause this and try these on your own. The derivative of h becomes h prime, right? The reason we're doing this again is they asked us to find h prime of c, and they give us c. But first we have to find h prime in general. So h prime is opposite of f prime. So now we can say h prime of 2. Notice I'm finding h prime at x, then I'm finding it at 2. Okay, f prime of 2. Let's look back up here again. 2 is in this region. And what is f prime in that region? Negative. So I have a negative times another negative. What is that going to give me? A positive. So I know h prime of 2 is greater than 0. Same thing here, h prime of x, now we need chain rule. The derivative of f is f prime, but remember when we have inside stuff, we have to take that derivative too, and that's just a 1. Chain rule. Now we have h prime of 3, which is f prime of 3 minus 12, which is f prime of -9. So let's go up here. -9 is in this region. The derivative is negative there. So I could say h prime of 3 is less than 0. Okay, that's all that it's asking when they ask you those kinds of problems. Okay, example 6. I mentioned before when we have graphs and you have to sketch derivatives, that it helps to have them lined up, so you can see I have this graph right underneath it. So this is f, this is what they're showing you, this is f, and they're asking us to graph f prime. Okay, some of these points I don't think they came out too clear. Let me tell you what they are. It looks like this point right here is 0, -1. And it looks like the other point is going to be 1, 1. Okay, so remember when we go to graph the derivative, the outputs are all the derivative values, the inputs will be the x value. But look what we have, a line has a constant rate of change. Can't we just even do like, think about rise over run? You go up 2 and over 1 between those 2 points. So this has a slope always of 2. Well, the derivative is just the slope. And if this has a constant slope, that means when I go to graph this line down here, or if I go to graph the derivative, it will be a derivative. It's just the horizontal line because it's the function. F prime is always 2. Okay, so at any given x, what this is saying, at any given x on this, we have a slope of 2. So that means at 0, the slope is 2. At 1, the slope is 2, and so on and so on. And that's how we get that horizontal line. Okay, the next one's a little trickier. If we go ahead, the first thing I want you to do is draw in horizontal tangents. Do you see right here, and right here? What we're going to do is drop those values down, and those are going to become the x-intercepts. Because what it's saying is that at this x value, and again, I know it's hard to read, at this x value, the derivative is 0. At this x value, the derivative is 0. And at this x value, the derivative is 0. Okay? Now we have this, we can start analyzing the graph. Look over here on the left. What is f doing to the left of this? F is decreasing, so the derivative is 0. If I start drawing tangent lines, look, I have a very negative, and then it gets less negative, and then look at it goes to 0. So very negative getting closer to 0. Okay, now look at the next, in this section right here. We go from 0 to positive, back to 0. So 0 slope, positive slope, back to 0. 0 slope, positive slope, back to 0. And that got really squiggly. Let's fix that. So we went up like this and then down. Now what happens on the next piece? We go from little negative to more negative, back to 0. Okay, so 0, negative to 0. It lines up with what we have, 0, negative to 0. Look at the next piece. This right here, f is always increasing on that piece. And because f is increasing, the derivative is 0. That means I have to be above the x-axis, and I have that. Here's another reason why this makes sense. This is a quartic. It's to the 4th power. If we recognize that w, remember when you take a derivative, you lower the exponent, and you get a cubic. Okay, on to 7, guys, almost done. Hang in there, a couple more. We have this function that's describing the motion, and it's going to ask us all these questions, I think 4 questions. Let's start off with A. Find the velocity function of the particle. Okay, no big deal, we got that. We know that velocity is found by taking the derivative of position. In this case, it'll be 2t minus 7. We got that done, out of the way. B. Identify the time interval or intervals in which the particle is moving in a positive direction. We know this. This is when velocity is positive. So what we're going to do is we are going to set the velocity function equal to 0 to find out when velocity is 0. And that will be at 7/2. Okay, instead of making an interval chart here, 7/2 is the only critical number. Let's just look at a number line. What if I was at 0? Because time starts, it says up here that time is greater than or equal to 0. Let's go to 7/2 and then we go on in the future. Okay, so if I'm testing the sign of velocity right now, which is also known as S prime, if I'm going from 0 to 3.5, how about a 1? Throw a 1 in here and you get a negative value. Pick anything greater than 3.5, how about a 5? Throw a 5 in here and you can see that this whole thing is positive. Okay, what's the reason? Particle motion I mentioned, if you remember this unit, always focus on your reason first, and that's your direction. It said identify the time in which the particle is moving in a positive direction. When is the particle moving in a positive direction? When the velocity, which is S prime, is positive, right? Normally it would say find when it's moving to the right, which we know is positive, but this one was really straightforward. Okay, so what we can say for B, the particle is moving in a positive direction for t greater than 7/2. Why? Because velocity was greater than 0. What's another thing for velocity? S prime. Remember, we want to show them that we know what velocity is. Okay, C, identify the time interval in which the particle is moving in a negative direction. Okay, the particle is moving in a negative direction when, look at your chart over there, for t less than 7/2. How do you know? Because velocity is less than 0, which is also s prime. Okay. So going on to D. What does D ask? Identify the time at which the particle changes direction. We'll try to think about it. When does it change the direction? The particle changes direction when t equals 7/2 because s prime, which is velocity, changes sign. You guys want to make sure that you just don't say it's when velocity is 0, because that means when it stopped. Even for a moment, we want to say it's because velocity changes sign. Okay, last one, example 8. Okay, on this one, they gave us G prime. Notice here that we are not looking at data about G, but instead G prime. It says if the domain of G is a set of all real numbers, so no domain restrictions, and remember we are not seeing anything about G right now, we only have its derivative, then G is decreasing on which of the following intervals? Okay, how about we write our reason first? This helps a ton this chapter. How do we know G is decreasing? Because G prime is less than 0. Now we have to fill into the left of it. Well, where is G prime less than 0? A common mistake is to pick just these numbers. Okay, but how do you know? Like, think about when you did this. Didn't you make a sign chart and you found when the derivative was 0? Then you looked at the numbers between them. Let's see, even up here. I know this wasn't a fully complete sign chart like we are used to making, but we found when the derivative was equal to 0 at 3/2, and we look to the left of 3/2 and to the right of 3/2. Look at now the derivative is 0. I'm looking to the left and the right of it. Another derivative 0, because this is derivative. So we do not want to say from -3 to -1. It's actually from -2 to 2, not including those. Okay, that's it for 3-3. See you guys.